Bidirectional forwarding error detection, BFD. Bidirectional forwarding error detection. Forwarding detection in simple word. BFD, with the help of BFD we can measure things like latency, delay, and so on. Not only error detection, it is also going to detect the status, up state, down state, link going up, link coming up, link going down, latency, delay, and things like that. So BFD can get all those things and provide us. It can get the latency of on the link. It can provide. So this BFD is like a protocol that can find out the bandwidth on the link, find out the jitter on the link, latency on the link, find the link status up or down, and report to us. This is a reporting protocol, BFD. Now, based on the report, we can take some action. We usually use this protocol to take action. We usually use this BFD with HSRP, or BGP or EIGRP or OSPF, or with all of them. This is the use case of BFD. We use it with these protocols so that when an interface goes down, when a link goes down, when a link goes bad, BFD will inform the protocol. For example, if I'm using BFD with EIGRP, BFD will inform EIGRP, I found the link is down. Then EIGRP will say, okay, let me take action immediately. Let me try to find any other alternate path. So EIGRP need not to wait for the EIGRP timers to expire. For example, for EIGRP to decide a neighbor is down, how long it takes? Hello, answer. Namaste ji. Namaste ji. I'm talking about EIGRP. I'm talking about EIGRP. For EIGRP to decide a neighbor is down, how long it will take? That is OSPF. 40 seconds is OSPF. How long EIGRP takes? I didn't expect this from Arindram. 15 seconds, Arindram. 15 seconds. 90 is administrative distance. So, when BFD reports to EIGRP about a link state, about a link going down, EIGRP won't wait for that 15 seconds to decide the neighbor is dead. It will immediately consider the neighbor is dead, and whatever the destination that was going via the neighbor, for those destinations, EIGRP will try to find an alternate path now. So BFD helps for fast convergence. So not only with EIGRP, even with BGP. As Arindram said, BGP takes 3 minutes. BGP takes 3 minutes for a neighbor. If neighbor goes down, to say neighbor is down, it takes 3 minutes. It takes 3 minutes for removing a route from the BGP table. When a network goes down, when the network goes down, BGP takes 180 seconds. That's what Arindram said. That is actually for BGP, he was telling, not for EIGRP. Maybe you didn't hear me well. For BGP, It takes 180 seconds to decide a network, to remove the root from a BGP table. It takes 180 seconds. That's the hold time in BGP. 180 seconds is 3 minutes. It's too much. Now you can ask BFD to make this faster for us. If you take BFD and give it to BGP to use, a BGP will wait for BFD, and once BFD says the link down, immediately BFD will take action. It won't wait for the 3 minutes. See, it won't wait for the 3 minutes. So simply BFD is used for fast convergence. So we have to first of all apply the BFD on the interface and then hand over that BFD to routing protocol. Please understand. BFD cannot work alone. The BFD probe messages, when you enable BFD probe messages will go and come. But no one will use the BFD unless you apply it. So just going and enabling BFD under the interface. See, I'm giving a clue parallelly. Where do we enable BFD? Under the interface. When you enable BFD under the interface, BFD will be running. BFD will be sending probe messages. For example, if I enable BFD on this port and this port, it will be sending probe messages to and fro. But what is the use? If probe fails, who wants it? No one knows about it. So you need to give this BFD to someone. That someone can be HSRP or OSPF, EIGRP, and BGP. Can be to any one of this or to all of this. So when you attach BFD to this protocols are going to take fast decision. How fast? Less than 50 millisecond. Less than 50 millisecond convergence. Listen, 50 milli is very small than 15 seconds of EIGRP. Oh my God, 50 million is very small. It's very small, not even a second. It's very small to a second. 1000 millisecond is 1 second. Now this is just 50 millisecond. Very fast. Fast is danger. Fast is danger. That also you should understand. See, you can go and change the timer in BGP if you want fast convergence. You can go and change EIGRP whole time, OSPF whole time, instead of using BFD. Why? Fast is danger. You know how much processor it is going to take? Terrible. If I use BFD in GNS3, it always crashes. Always. I've never seen even single time a report. BFD always crashes our GNS3. You try. So definitely there's a big impact in the production. On the real device, it may not crash, but the process utilization is going to be very high. Because the probe messages are sent every 50 milliseconds. And you hand over to a big protocol like BGP, even EIGRP, They consume a lot of processor. Let us now go and see. I have tried earlier with GNS3 many times and always it crashed. Always I used with OSPF, I used with BGP, I used with EIGRP, always it crashed. Today I'm going to do it on EVE and see whether it will work. I've never tried with EVE. In this topology, actually I have already enabled BFD. I'm going to on one router and show you that. And then I'll remove it. And then I'll reconfigure it. I'll redo it. R1 switch. R2 I'll not start now because it will crash. That is also configured with BFD. I'm just having R1. You see, pay attention. First we need to configure on the interface. Show run interface F0/0. You see? Oh, it's not configured, no problem. We'll configure now. Good news. So we are going to configure BFD. Interface F0/0. Take down the commands. It is good to enable logs so that you can. Okay, let's do one thing. We'll not enable logs. Sometimes logs also will consume a lot of processor. But for your information, I'm typing some command, but I will not hit enter. Service. No, global mode. Service timestamp log show date and time in millisecond. Note down this command. It will show you logs in millisecond. I will not hit it. I will not hit enter. Why? This also may be the reason for why it is getting crashed. Logs, too much logs coming and occupying my buffer. In GNS3, it's not good. Okay, so you might just make a note. I'm not hitting enter. I'm just trying, without these this command. Usually the logs will not be shown in millisecond. Only in seconds it will show. Have you finished copying? Shall I erase it? Kindly respond. Yes. Right, now I'm going to go to the next one. Same service timestamp. For the debugs, same date and time in millisecond. So when I on debug, I want even the millisecond debug because it's going to converge in less than 50 milliseconds. So I want to see all the details, for which you need to enable this command. But I'm not going to enable this because I don't want to see crashing. Have you copied this? You said yes? You need to copy this one, this command and this command. Okay, that M stands for millisecond. Now, I don't apply it because as I said, the logs will be too many because less than 50 millisecond. Then 1 second itself is very short. 50 millisecond is very, very short. GNS3 will crash. It has crashed earlier, that's why. Next is how to enable debug. This is the command. Debug BFD events. There are many things. Events is better. Packets also you can say. Debug BFD event or packet. See, this is all you can use with approval in production. Don't do without approval. You will be fired out of company, I tell you. because this is going to crash. Also show Bfd Neighbor. This is also a command to see whether see when we enable BFD, we will enable on both R1 and R2. So to check whether BFD has come up or not, we use this command show BFD neighbor. Fine. Now I am not typing any BFD debug command. That may be the reason why every time it crashes for me, because debugs coming every 50 second, 50 millisecond, it's going to be a huge buffer utilization. Now, what I'm going to do is first I'm going to show you in a routing protocol, show IP protocol. Let's see what protocol I have. I have OSPF. I'm going to show you how to apply BFD in OSPF. Later I'll show you how to apply it on EIGRP and BGP. Are you ready? No. Now for any protocol, you need to do this. You need to go under the interface and enable BFD by saying interval. It can be any interval between 50 millisecond to almost 1 second. 999 millisecond. 1000 millisecond is 1 second. See, this is 1 second. This is 1 second. This is 1 second. 50 millisecond is very small. Very small. So, see the gap in between? The gap in between? 20 times less than that gap is 50 millisecond. See how much CPU it will consume. If I say 50 millisecond, BFD should send a probe message every 50 seconds. There is also another command called minimum receive, meaning from the neighbor, I'm expecting BFD packets to come every at least 50 seconds, every 50 seconds. And then for this hold time, I'm saying multiplier maybe 3 to 50. I'll say 50. Now, BFD is running on this interface. Let's enable BFD on the other side with the same command. When I say let's enable, I'm not going to really enable because it may crash. I'll do it at last. At last. I'm just showing you the commands with OSPF, with EIGRP, with BGP, and at last we'll try to apply it on both the sides. Okay. So have you noted this command? You need to repeat the same command, same configuration on R2F00. Only then the BFD neighbor will come up. You need to repeat the same command on R2F00. So let me put it in a notepad. Interface F0/0, you need to apply this. Before that, what all we did? Before that, nothing we did. Those are all simply for you to get the packets and deep dive, like service, timestamp, date and time in a millisecond. These are all just for you to see the logs in millisecond. And then service timestamp, log, date and time in m second. So these are all optional. And then show command is show BFD neighbor. And then for debug, BFD, this is the command debug. BFD events or packets. Right now, the very first important command that we have to do is under the interface. That's all configuring BFD. Now you have to give this BFD to someone to use. We are planning to give it to OSPF. Let's give it to OSPF now. This command which you have just done, it is not only for OSPF, it's just to enable BFD. It can be used by OSPF, it can be used by RIP, EIGR, not RIP. It can be used by OSPF, EIGRP, BGP, HSRP. Now let us see how to assign it to OSPF. Router OSPF 1, BFD, you see, all interface. See, in OSPF, you don't have an option to say run only on this interface. But in BGP, you have an option to say run on F00. Yeah, you will say for neighbors. Right? So, I hit enter. That's all. We have allocated BGP to OSPF. If any failure happens in the link, OSPF will do fast convergence. It won't wait for that 40-second. Right? So let us now remove OSPF. No router OSPF. OSPF1. And EIGRP, let's see. Router EIGRP1. For EIGRP, the command will be BFD. See, you can specify interface F0/0. That's it. Right. Now let us go to our final protocol, BGP. It's okay. Let us have EIGRP or OSPF, router OSPF1. I'm putting back OSPF because the other router is running OSPF. And then I go under interface F0/0, IP OSPF1 area 0, and then interface loopback 0, IP OSPF1 area 0. Now I'm going to apply this BFD to OSPF as well as to BGP. Interface, router OSPF1, BFD, all interface. Right, now OSPF is ready with BFD. Now router BGP, let's say autonomous system 10. Neighbor is 12.12.12.2. Remote AS is 10. Both router 1 and router 2 are going to be in same autonomous system. 10. Now, network I want to advertise is 1.1.1.1. Mask is 255.255.255.255. When a neighbor goes down, usually this network will be removed after 240 seconds. But with BFD, it will be removed immediately. That is the verification that we need to do. If GNS don't crash, then we can see that. Okay, next what I'm going to do is I'm going to see enabling BFD in BGP. This is the command. Neighbor 12.12.12.2 fall over using BFD. Meaning, if BFD says the link is a problem, the neighbor is unreachable, immediately you fall over, meaning try to find another solution. Try to remove this neighbor and find some other solution. That's what fall over means. Fall over using BFD. That's it. That's all. So I have enabled BFD and assigned it to BGP and OSPF on router 1. I'm going to keep this interface shut for some reason because I do not want to crash before you see something. I keep this interface shut down. Let's move on to router 2 and finish the configuration now. All right. Config T. Okay, before that, I want to say show IP interface brief. Okay, we got the Lubets. We also got a network 22 network and fine. I'll go to router 2 and say do show IP protocol. First, I'll check what routing pro. Okay, we already have BGP. Let me remove that BGP. No router BGP 20. Now we got only OSPF, and OSPF is running on both Lubeck 0 and F00. Good. So we have to go straight to OSPF now. Router OSPF 1, BFD, all interface. That's all. Next. Router BGP 10. Neighbor is 12.12.12.1. Remote AS is 10. Network is 2.2.2.2. Mask is 255.255.255.255. And now I'm going to have BFD enabled. Neighbor 12.12.12.1 fall back, fall over using BFD. But I need to make sure the BFD is running on the interface. Let me go and check. Show run interface, show run. Interface F0/0. Yes, it is already running. But let me change the multiplier value. Multiplier 3 is too small. So it will be like 150 seconds. I don't want that. I want it to be as maximum as possible, like 50 times. Done. Show run interface F0/0. All right, 50. Oh my God, look at this. It's already started. I didn't even on that other side. This is the problem with the, see the track. It is all because of the tracking. It's very fast. The idle within the scheduler process, sorry. So that's all actually we have configured. But R2 was trying to send the BFD packet and it got crashed. I didn't even turn on R1. As soon as I turn on R1, you will see that R1 will also get into a problem. Okay, the link has come up. Now R1 F00 will try to send, okay, the BFD probes. And again it will get into a problem. Till now it has not come. Now it will come. No, it is going to try now. Now BGP is seriously working. Let us see some Wireshark output and see what is going on from R2. Between R2 and switch 1, BFD is crashing, no? So we will see what R2 is sending. Usually Wireshark won't take this long. It's all because of BFD. Can I filter? I don't think BFD is captured. Hmm. Now it's totally jammed actually. Nothing is coming. Only the router is showing the log. Nothing is coming out. What about router one? By this time, router one will also have the same problem. No, that's good. Show IPBGP summary. It's an idle state. Ping 12.12.12.2. The router is crashed, so you will not be able to receive any packet. Let me shut down and unshut. I'll see the router has gone down actually. Shut down. I'll stop once. Even I have got a processor issue. You see, Dynamics hypervisor processor has been stopped. That's why you should not enable BFD. See, oh my god, it's serious issue. Sorry. BFD